Hello, I'm Frixius, the developer of Neos VR, and I have another development update for you. So I'm currently using the Vive Pro Eye VR headset, and if you carefully look at my avatar, you can see that it's working. So essentially, I have the eye tracking completely integrated with Neos VR, and if you have any avatar that already has the eye set up using the eye simulation, it will automatically pick up the eye tracking and it will use it for the eyes instead of the simulated one. So you can see I can look left, right, up, down. I can squint. I can squint up, squint in the middle. I can also do their face. And so essentially, like the solution, it works automatically with all of the avatars without having to do anything extra if we have the eyes already set up. But if you don't have eye tracking, it's just gonna use the regular eye simulation. But there's even more. If you want to use it for other things like research purposes, there's actually even more data, and I'm gonna show you in a second. But let me just show you a bunch of different avatars, how well it works with lots of different ones. Let me actually bring up my inventory. So let me use this is the human one. So you can see left, right, up, down, squinting, doing the derp face. Actually, the derp face, I'm not actually doing it with my eyes, but what I'm doing is I look left, I close my left eye, and I look right. So essentially, one of the eyes is not reacting anymore. And currently, it's like that because essentially just using the raw data coming from the device. But later on, I'll make it so when one of the eyes is not actually tracking, it's gonna use the other eyes, so they look more normal. But I thought I'd leave it in for now, just so it's a little bit of a fun thing. So let me try another. This one actually works pretty well. So it's like a anime character, and the eyes they have pretty big range of movement, so it's very easy. It's very easy to see like what's going on with them. Let's try another one. So what can I try? Let's try this one. This one is more cartoony. So and you can see I'm also looking around, squinting. So it should work with a variety of different characters without like needing to do much. Let's also do this one. Come on. There we go. It's loaded. As you can see, I can look at my nose. I can even follow my finger. And squint, do the face again. So it should work with a variety of them. But like the pure like visual aspect of it, that's just one part, and that's done completely automatically. But if you want to do more, if you want to do like some technical applications or research, there's actually I have another avatar that I've prepared for testing this. You can actually put a component on your avatar which allows you to access more of the data because it doesn't track only the eye direction where you're looking, but it's tracking some other data as well, and I'm going to show you. But so as you can see at this one, I'm looking at the tip of my finger. I'm following it with my eyes. I'm looking at the inventory. I'm looking at the close button. I'm looking at the corner. I'm looking back at the camera. I'm looking at the display above the camera. I'm looking at the camera now. So looking around, crossing my eyes. So you can actually see like it shows these essentially arrows which point to where I'm looking. And that's just a very, very quick example I've made with this avatar. But if I use the developer tooltip, this is actually done by attaching a special component to the head of the avatar, which allows you access all of the data coming from the eye tracking system. So if you look over here on the head, there's a component called avatar raw eye data, and you can see there's data for left eye, right eye, and combined eye, and some extra. Although it doesn't seem that the Vive Pro Eye currently tracks convergence distance. And for each eye, you actually have you have the whether it's tracking. So this is the left eye. I'm gonna close my left eye, so you can see it actually stops tracking when I close it. You have the origin. The origin is actually the relative offset of the eye relative to the headset. The important thing to note that the offset is not relative to the head of the avatar. It's relative to the headset. So you cannot use it as a relative location here of the head. You need to actually take the head proxy and use compute the offset from that if you need to if you want to use that information. You also have the direction. That's a normalized vector, and is actually what's being fed into these visualizers. And you also have other interesting parameters. You have the pupil diameter. This is in meters, so essentially this corresponds. This is 0.0026, so that's about like 2 millimeters, 2.6 millimeters, and it's actually constricting. There's also eye openness, so essentially that's a normalized value. So I'm sort of half closing my eye. I can see when my eye is fully open, it's gonna be 1 or near 1, and when I close it, it's gonna be 0, and everything in between essentially showcases. Everything in between is essentially like your eye sort of closing. In the future, once we have the plane shape support as well, there'll be automatically, if you set up blinking and such, it'll be automatically mapped to the avatar as well. But for now, you can just use the raw data coming from the SDK if you need to. And let me actually show you one quick thing that you can do with this, because using this component, you can find it, by the way, if you want to attach it to your own avatar, you can go to Users, Common Avatar System, and Face, and there's the avatar raw eye data. So let me just show it so you can see it better. But I don't need to attach it because I already have one. So I can actually use the visual scripting for to utilize the data in some ways. So let me bring up LogiX. And one thing that I find a really cool example is actually using the pupil dilation. So what I'm gonna do is when I want to extract I'm gonna use the left eye. So I hover over the left eye and I pull it out like this. So the important thing, like you cannot pull out the avatar eye data because essentially it doesn't contain the information. It's contained within this sub-object. So you can see this is the eye data. This is for the left eye, and I have the pupil diameter. And what I can actually do is I can apply this to a scale of an object. I'm gonna exaggerate it so you can see what my pupil is actually doing. So I'm just gonna go back to my inventory. So let me bring it here. I need the shape tool. Let me bring it back here. So I'm just gonna make a sphere like this, and I'm just gonna put this here. I'm gonna grab my LogiX tooltip, and actually hold on. I need to open the inspector for this. It's actually pretty weird, like when I'm doing this, because like having these arrows coming out of my face makes me realize where my eyes are going, like where I'm actually looking at, because like normally you don't really think about it. So let me just pull out the LogiX interface for the sphere, so I can access its transform. And what I want to do is I want to actually take the pupil diameter and apply it to scale. And because this is in millimeters, this would make the sphere very, very tiny. But I'm gonna exaggerate it. Actually, let me deselect my face. Hold on. There we go. Deselect it. So what I'm gonna do, I'm gonna take the pupil diameter, and let me just move the sphere over here. I can actually see it on the camera, as you can see. So what I'm gonna do, I'm just simply gonna take the value and I'm gonna multiply it. So let's plug it here. Let's plug the display here. And I'm gonna multiply it, by 100. So this would be about 30 centimeters. So essentially that's a factor of 100. So when it's 3 millimeters wide, this would be 30 centimeters big. We have like a radius of 30 centimeters. But because the scale, it's a 3-dimensional vector, I need to pack this value into a vector. So I'm just gonna use it for the same as the component, each component of the vector. So essentially it's uniform scale. And then I simply plug this into the scale of the sphere. Oh, and actually this is still too small. Why is it too small? Oh, this is, oh right, this is actually, that's because of, I didn't make the sphere 1 meter, like 1 meter in radius. So actually, I need to make it a little bit bigger. So I'll make it big like this. There you go. That's because the scale is essentially scalar relative to the like a normal size with the object. And we can actually see what my pupil is doing. You can see there's quite a bit of noise. So what I'm gonna do is, let me actually scale it a little bit less. Let's go like 500. There we go. This is easier to see and it doesn't mess up my circuit. But what I'm gonna do is I'm gonna smooth it out so I don't have so much noise. So what I'm gonna do is I'm gonna pull out a smooth lerp from Mouth, smooth lerp. And we're gonna plug the pupil diameter. I'm gonna use a smoothing factor of 5. And just gonna plug this here. And you can see now it's a little bit better behaved. And now the really cool thing is you can actually see like I'm in sort of a dark environment. And if I'm looking at the sky, I actually pull out the skybox. I'm gonna extract the skybox. So I have the skybox here, and I have the parameter exposure. So let me set it to 0. And we also actually darken the ground. So I have as much darkness as possible. So let's just make this black. There we go. There we go. There we go. Okay, let me increase it to about 1000 so we can see it better. And we can see this is the size of my pupil multiplied by 1000. And now what I'm gonna do, I'm gonna suddenly increase the exposure of the skybox. I'm gonna make it really, really bright. And watch carefully what my pupil does. Okay, ready? Do you see that? Did you see that, like how it constricted? Make it even brighter. Oh god, now I cannot see anything. There we go. And I can see how it's getting bigger again. Smaller. Bigger. I can actually automate this, so I'm gonna pull out LogiX interface for the skybox as well. So let me actually just move this over here. So what I'm gonna do, I'm gonna take the projection material. I can close this because I don't need this anymore. I have the exposure parameter. So what I'm gonna do is I'm just gonna make it change every, let's say, every 5 seconds maybe. So let's use flow. I'm gonna use timer. It's gonna be simpler now. So let's say 5. And I'm gonna use a Boolean ledge, which is also in the flow. There we go. Boolean ledge. So I have set reset toggle. So I'm gonna plug it to toggle. So you see this is gonna give me a Boolean that toggles every 5 seconds. And now what I can do, I can actually assign exposure based on this. So I'm gonna go to operators. I'm gonna use the conditional operator. I'm gonna plug this as the condition. And now I will take, this is the exposure is float. So I'm gonna plug a float. So one of them is gonna be 0, so it's gonna be dark like this, and one of them is gonna be 10. Let me try it, or maybe 20 even. Not sure if that's gonna be too bright. And now essentially I have a value. Oh, I cannot see it too well. Sorry. You can see like the value, it's changing from 0 to 20 every 5 seconds. And now all I need to do is take this and plug it to the exposure. Oh, and this is bright. This is really, really bright. And it's dark again. Let me change it to 10. So it's going from 10. Ah, bright, bright, bright. And watch this. I'm gonna make the, oh, bright, bright, bright. I'm gonna make the sphere a little bit, I'm gonna make it glow so you can see easier. Actually, I'm just gonna use a material that doesn't respond to light so you can see it both when it's bright and when it's not. So let me just grab another material. Did I leave my other inventory somewhere? I think I closed it. So let me just use whichever would work well. Let's actually use the diagnostic one, which shows normals, because this is, there we go. Right, you can see it gets smaller and dark, and you can see how it slowly expands. It's actually kind of fun, like thinking about this. So anyway, let me switch back to my normal avatar. Let me change the Skybox, so it's not so bright. Just 5. That's good enough. So let me just switch back to my normal avatar. So I can properly say goodbye. So thank you very much for watching. I hope you really like this update. Mostly, I think this is... Oh, I'm getting pierced by these eyes. There's a piercing stare. So I hope you like this video. I think it's mostly interesting for research purposes, and it's one of the reasons I've actually implemented this system, is because it was requested by the Sydney Human Research Factors, who are one of our biggest users, and also the Weizmann Institute, and we actually have some other parties interested in this as well. And especially thanks to LogiX, because you can pretty much build any application within VR with the eye tracking system. But even for casual users, if you happen to have Vive Pro Eye, you can use it for your avatar. It adds a fair bit of expressiveness. It will add even more once we actually have the blend shape. So it actually, when you close your eye, it doesn't do this, but it will actually close your eye. And that's pretty much it for now. So if you have any questions, you can feel free to ask me in comments. And you can also support this project on Patreon if you'd like to support the development. And we also have official Discord, so check the links in the description. And I'll see you with the next update. Bye-bye.